Good morning, HKUST. It's a pleasure to be here. Betty is this amazing force. So is HKUST. This is our truly first Asia push, right? So, Georgia, myself, and others at X have worked very hard on other regions of the world, but we're thrilled in the next couple of days that we're going to spend more time here to build a community. So what I'd love to do is, since you couldn't join me in California to take a look behind the scenes at Google X, now formerly known as X, I thought you might enjoy taking a look at a few pictures and how we think, how we build self-driving cars, how we build energy kites, et cetera, et cetera. So let me start with a quick video and then show you a few photographs.
The actual moonshot is wonderful, inspirational, poetic, beautiful, involved great technical challenges, genuine heroism. It brought the world together. But think about the Polynesian islander on the dugout canoe, deciding one day they were going to go that way. No one had ever been that way before. No one even knew if there was anything that way before. It was amazing, and it changed the world.
People can set their minds to magical, seemingly impossible ideas, and then through science and technology bring them to reality. And that then sets other people on fire, that other things that look impossible might be accomplishable.
Galileo is such a hero, in thinking big, and what he represents to me is both curiosity and wonder that humanity had, that he had, that pushed him and drove himself to invent and work on the first telescopes that allowed us to see the moon, and here we are.
These aviation pioneers were figuring it out as they went. No one really knew how to build an airplane, right? No one knew how to fly an airplane. It was amazing and crazy and wonderful, and they wanted to explore.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there.
There's so many challenges in the world, and you can feel daunted by that, and sort of oppressed by that, or you kind of say, how might we think differently about this?
Everyone else in the world is working on that next 10%. If you can be the one that delivers that 10 times improvement, you have a chance to really change things.
If you want cars to run at 50 miles per gallon, fine, you can retool your car a little bit. But if I tell you it has to run on a gallon of gas for 500 miles, you have to start over.
You need a lot of courage in this work, and you need a lot of persistence. One of the things that's really critical is not only having the courage to keep trying every day or thinking big, even if you don't really 100% believe it's possible, like you might think, this might be possible, have the courage to try. That's how the greatest things have happened.
You don't spend your time being bothered that you can't teleport from here to Japan, because there's a part of you that thinks it's impossible. Moonshot thinking is choosing to be bothered by that.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Humanity's progress has been a series of amazing, audacious things, from the very small and personal up to the great, big, and grand. And we are a species of moonshots. And to me, that's like the really amazing, poetic, and inspirational thing.
I think our ambitions are a glass ceiling on what we can accomplish.
When you find your passion, you're unstoppable. You can make amazing things happen. It's been true through all of history.
I believe in the human spirit, and I believe that there are always going to be crazy people who will get out of bed one morning and say, you know what? I think I can build a space elevator, and we'll just go and do it. But I think that if we become afraid to take these great big risks, we stop inspiring people. We stop achieving things. And the biggest nightmare scenario is that we won't have what it takes to solve the really big challenges.
When Kennedy said that we would put a man on the moon, it's about the fact that he said, we don't know how to do this yet, and we're gonna do it anyway. And that sends chills up everybody's spine. Because if that happens, what couldn't we do?
Did you enjoy that? Was that fun? Okay. So those were a few words from Astro Teller, who is our CEO for X, Rich Duvall, who is the head of Rapid Evaluation, which is where all moonshots start, and then Megan Smith, who is actually now the Chief Technology Officer of the United States of America. Obama gave her a call, so if President Obama gives somebody a call, we can't really keep her anymore. So just a quick look behind the scenes. We exist to invent and develop radical technologies that will change the face of humanity. We are now formally X, so when Google restructured in August, we are now a subsidiary of Alphabet, which actually allows us to be a lot more free to do all the things that you see on the screen here that didn't quite fit under Google as a search engine company. So quick review, you've seen the diagram on the right already. Every project that we have involves some sort of breakthrough technology, obviously, but we always begin with a huge problem. Generally, we do some really, really interesting things, but focusing on the user is the very, very, very crux of the heart of what we do. So what do I mean by a huge problem? Something that affects 500 million people in the world or more. And those are the problems that are worthwhile solving, because if you think about it, if you could actually solve a problem for 500 million people or more in the world, you're generating value and you're making meaning, and then the money will follow. So, huge problem, right? If you look at something like the smart contact lens, there's over 500 million people in the world who will have diabetes by 2050. That's a really, really sizable problem to solve for. Self-driving cars, really cool tech. There's 1 billion cars on the road. 1.4 million people every year die of car accidents, of which 90% could have been prevented because of human error. Project Loon I'll dive deeper into for a moment, but there's 3 billion people on Earth who don't have internet connectivity. The fact that you have a cell phone in your pocket and access to the world's information makes you very, very unique, and you're in the minority. Most people in the world don't have that. So let me dive a little bit more deeply into what it looks like. We build things, right? So who knows of Google Glass? Probably, right? Okay, so Google Glass is now graduated to Nest under Tony Fadell. Early on, we built probably hundreds of prototypes within weeks of starting the project. So behind the scenes, it looks a lot like this. People are building things, getting their hands dirty, trying new iterations, wearing these things around the office, right, and really getting to know what the user experience would be like. One of the core tenets of X is that you get your hands dirty, you combine theoretical science and engineering with applied science and engineering. And I see this at HKUST in your labs, which is super, super exciting. Those are small things. We also build really, really big things. So this is something that we think of as the next generation wind turbine. So this picture I don't think has been seen publicly before, so forgive me if I'm going to ask for your discretion here. We believe that we can generate 10 times the wind energy by using a self-flying airplane. So this is basically a self-flying airplane on a tether. We call it an energy kite. This is the M600. It will generate 600 kilowatts when it flies, and it's 10x lighter than the standard horizontal axis wind turbine. There's enough wind in the world to power all our energy needs. We just can't access it right now with a traditional horizontal axis wind turbine. So yeah, it didn't quite fit under Google, right? So now that we're Alphabet, we can go and build carbon fiber structures and infrastructure for energy and utilities. We also build other sorts of flying things. So this is Project Loon. This is one of my favorite. We have flown thousands of these large stratospheric balloons to put cell phone towers in the sky. So what's interesting about this is that if we dive a little bit deeper, most people in the world are not connected. Most of the geography is uncovered because it's very expensive for a telecommunications company to build a cell phone tower on the top of a mountain for one goat farmer, right? Cell phone tower costs $500,000 maybe in the US, right? Also, if you look at some place like Sichuan province, when there's a large earthquake, suddenly 80 million people may have lost their internet connectivity, and that's the point in time when they really, really need it. So we think this is a pretty worthwhile problem to solve. And how does this work? So crazy idea, radical solution, right? So instead of building more and more cell phone towers into places that are very hard to put them, why don't we think about floating them in the sky? So if you're a user, let's say you're that goat farmer, the one goat farmer within a 500-kilometer radius, you're the only person there on the mountain, right? You should take your LTE device, your 4G device, and be able to connect through a network of balloons in the stratosphere and seamlessly connect to your telco company, right? And this is actually very, very possible. We're in the process of actually making this happen in the next 3 to 4 years globally. So what's in the breakthrough technology here? A lot of material science, which I know there's a number of you in the audience, to keep the balloons, firstly, up in the stratosphere where it goes down to minus 80 degrees centigrade at nighttime. A lot of really strong work on guidance, navigation, and control. So in the stratosphere, the winds are actually incredibly stable. So if you know which direction the wind is going at 21 kilometers versus 22 kilometers altitude, you just have to go up and down. So the only variable that you can change really is altitude, and you can navigate along the coast of Madagascar, for example. We can adjust the network as needs increase in certain areas or decrease in certain areas. And finally, as I spoke about, we can connect directly to people's cell phones without any additional infrastructure. So currently, what we have in cities around the world are cell phone towers on the ground, which are great when there's incredible density and population. But most places in the world look more like on the right side of the screen here, where people are dispersed in rural and remote areas. And it's very exciting to see this technology start to really bear fruit. So I wanted to finish with two things. Here's a quick video of what Project Loon looks like in real life. It's not a lab bench project anymore, which is where I'm getting really excited about it. And then a few words from Astro Teller, who is our CEO. He sends his regrets that he could not be here in person today, to thank all of you for your participation. And in true form, he's wearing his rollerblades and his computer is covered in stickers. So forgive him, he's not a traditional CEO.
The goal of Project Loon is to bring internet to the almost 2 out of 3 people in the world who don't have internet access today. And we're doing that using high-altitude balloons. 3, 2, 1. The very first tests we did showed that it could work. So we began to think, wow, we're going to need to have a manufacturing system that can manufacture many, many of these balloons. We're going to need to have a mission control system that can keep track of the balloons. We're going to need to have an operations team that can launch these balloons and then recover them when they're ready to come down. So each piece of the process got to be bigger. It had to scale up. It was pretty challenging, getting the balloons to be more durable and more long-lasting. For a while, many of them leaked for some reason or another, and they would come down over the course of a few hours or a few days. It was like a detective job to figure out what was introducing tiny leaks. Now our balloons last over 100 days. At first, it would take us 3 or 4 days to tape together a balloon. Today, through our own manufacturing facility, the automated systems can get a balloon produced in just a few hours. We're getting close to the point where we can roll out thousands of balloons. In the beginning, it was all we could do to launch 1 balloon a day. Now with our automated crane system, we can launch dozens of balloons a day for every crane we have. To steer 1 balloon left or right, you actually go up or down. And that's because in the stratosphere, the wind goes slightly different direction at a different altitude. To provide continuous internet service, you're talking a complex choreography where thousands of balloons are being steered and programmed all in an automated fashion. So another balloon is coming just at the right time to take its place of the one that left. Our mission control system allows us to track every balloon and lets us optimally position the balloons to provide coverage exactly where the people needing internet coverage are. We can track the location and projected trajectory of every balloon from the moment we launch it on the way up till it reaches altitude, from the time we decide it's ready to bring it down, all the way down the descent till a spot on the ground. With our system, we use LTE, which is a common protocol that most of the telcos around the world use. So anyone with a smartphone anywhere in the world will be able to get internet access. One of the key things we do is we partner with the local telco in every country. In New Zealand, we're partnering with Vodafone.
We like to think of ourselves as being very innovative in Vodafone New Zealand, so we thought this was a great partnership. Project Loon allows cell phone companies and internet providers to provide an internet to communities that don't have it. Ultimately, the goal of any internet service provider is to have 100% geographic coverage and all the capacity and speed that people expect. Project Loon will help deliver that.
If you look at the system today, it's amazing how much more advanced it is, from being 10 times higher data rate to the balloons lasting over 10 times as long, to the steerability of the balloons. We've flown in the tropics, we've flown in the Arctic regions. The technology is working. We're getting close to the point where we can bring the internet to people around the world.
So I know that you'll hear a few more moonshots today from HKUST. I think every moonshot that you have here has the potential to scale up like Project Loon, which is super exciting for us. And one of the really key things that Astro will touch upon in a minute is that we know that there's moonshot thinkers all over the world, and the reason why we have Solve for X is because we want to support moonshot thinkers who are not necessarily huddled in the lab that we have in Mountain View, but are in places like HKUST and in Africa and Europe and wherever they are. So we set up the platform Solve for X a few years ago to really, really help others progress as well. So a few words from Astro Teller to finish.
Good morning, HKUST. Congratulations on your first Solve for X event. I'm glad to be here with you in spirit. When Eric Schmidt and I started Solve for X back in 2012, we did it because we wanted to make sure that the world understood that taking moonshots is something that we can all participate in, not just the people here at X. All around the world, we've found scientists, inventors, artists, entrepreneurs who are excited to work together with each other, to work together with us, to find ways to make the world a radically better place. In the past few years, we've run over 60 Solve for X events around the world, seeing hundreds of moonshot proposals that range from new ways to treat biology as a form of engineering, ways to make thermally stable nuclear reactors, ways to use big data to cause food production around the world to be wildly more efficient and effective than it is today. We're looking forward to hearing from the people from HKUST who are going to talk to us about things such as mass production of graphene, working to reduce degenerative eye disease, and other areas. In 25 short years, you've grown to be one of the leading academic institutions in the world. That you're taking this next big step from talking about the work to really pushing it out in the world to ensure that the impact that you've imagined can actually occur in the world is an amazing thing to see, and we're happy to be able to be celebrating it with you. Have an excellent Solve for X conference today. Good luck.
Thank you.